We now have a radical equation that we'd like to solve. And looking at this, it's a little bit intimidating. So before we dive into it, what I'd like to do is look at a simpler problem to give us some idea as to how we can approach this one using some first principles. The problem that I had in mind was trying to solve the square root of x equals 5. Where our goal is to turn the square root into an x. And the way we can do this is we can just square both sides. Squaring the left-hand side gives us x, and the right-hand side gives us 25. So we now have a method that we can use to solve this guy. Namely, we want to square away the square root. That's going to be our goal and our process. Well, I could square both sides now, but I'd actually get somewhat of a mess on the left-hand side after I FOIL things out. So the first thing that I'm actually going to do is bring the 4 over to this side to get that the square root of x equals x minus 6. And now I'm going to square both sides. So we have that the square root of x squared equals x minus 6 squared. Caution. Lots of students are tempted to take this 2 and distribute it. But that's actually not quite correct. And if you're unsure about, in the misconceptions section of this website, I talk a little bit more about this. Instead of distributing it through, what you need to do, let's see, the left-hand side is just x. You need to FOIL that guy out. So let's do that. This is x minus 6 times x minus 6. And it looks like the left-hand side is x, while the right-hand side is x squared. Minus a 6x, minus another 6x, plus 36. So it looks like we've turned our radical equation into a quadratic equation. How do we solve this? We're going to set it equal to 0, and then either factor, complete the square, or use the quadratic formula. So let's take a look at this. Well, if I subtract x from both sides, I'm left with 0 on the left-hand side. Let me subtract the x from both sides. X squared. And let's see, I've got a minus 6x, a minus 6x, which is minus 12x. Minus x is minus 13x. And then we still have the 36. So let's see if we can factor this. And again, if you can't factor it, no big deal. You can always use the quadratic formula. Might be a little bit of a pain since these numbers are a bit big to use a quadratic formula. So again, let's see if we can factor it. Well, we need two numbers that multiply together to give us 36 and add together to give us minus 13. How about minus 9 and minus 4? Minus 4 times minus 9 is 36. Minus 9 minus 4 is minus 13. Looks like that's going to work for us. So now we have the product of two things equaling 0. What this means is that at least one of those guys has to be 0. So let's set each one equal to 0. This tells us that the two possible solutions are 9 or 4. But you have to be a little bit careful with square roots, because with square roots, for example, you can't take the square root of a negative number. So you have to double check that these guys actually work. In other words, our first equation was a radical, was a square root, but we transformed that equation into a quadratic. These guys solve the quadratic, but may or may not solve the radical. So let's take a look, see if one, both, or none of those guys work. So plugging the 9 in, we get the square root of 9 plus 4 equals 9 minus 2. Let's see, that's just a 3. Let me put a question mark here. Yeah, this is looking good. So it looks like the 9 is one of our solutions. Let's check out the 4. So sticking a 4 in, we have the square root of 4 plus 4 equals 4 minus 2. So this becomes the square root of 4, which is 2. Again, let me put a question mark. 2 plus 4, does that equal 4 minus 2? Not on Thursdays. So I guess this isn't going to work for us. So we'll cross this guy out, and it looks like x equals 9 is our solution. So the process that we followed is we started with our radical equation, and we wanted to get rid of the square roots. So to do this, all we did was square them away. In squaring, we reminded ourselves that when you square x minus 6, for example, you needed to FOIL that out. We then developed a quadratic equation for which 9 and 4 were solutions. But again, just because they're solutions to this guy doesn't mean they're solutions to the original. So we had to check that out. We plugged it in to take a look, and we found that only 9 was the actual solution.